Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi. Today I would like to share our research work with title Performance of Image Enhancement Methods for DR based on retinal fundus image. Our research team including Nurul Atikah Muhammad Sharif, PhD candidate from UUM, myself, Nor Hazlyna Harun, Yohanis Yusof, ophthalmologist from HUSM, Associate Prof. Sunaina Embong, Juhaida binti Abu Bakar, Muhammad Kushairi Osman from UIT and Penang, Nurul Fatin Shazwani Shamsuddin, and Lim Zio Feng. The outline for my presentation, including introduction, research objectives, previous works, methodology, results, and conclusions. As an introduction, what are diabetic retinopathy? Diabetic referring to condition of high sugar level in blood, while retinopathy referring to disease of retina affected from long duration of diabetic. Therefore, diabetic retinopathy or DR, known as abnormalities of the retina due to prolonged diabetic disease. Diabetic retinopathy, also known as microvascular disease, which is disease that related to small blood vessel less than 0.3 milliliter. However, diabetic retinopathy also categorized based on retinopathy staging. For early stage, namely as non-proliferative diabetic retinopathy or NPDR, and advanced stage known as proliferative diabetic retinopathy or PDR. Figure 1 shows DR stages from right hand side is normal retina, and in the middle is PDR, and left hand side is NPDR. Next, figure 2 shows fundus image samples captured using fundus camera and collected from HUSM, Hospital University Science Malaysia, Kubang Krian, Kelantan. For figure 2A is normal retina fundus image, while figure 2B show NPDR with feature hard exudate. And figure 2C for PDR with features hemorrhage and new vessel Okay, now we look for the present situation for worldwide. From Lancet Global Health 2017, 1/3 people with diabetics have diabetic retinopathy. 2.6 million people were visually impaired because of diabetic retinopathy, and projected to rise to 3.2 million in 2020, this year. Also from DR, Lancet Global Health DR has declined in high-income countries because of excellent intervention. Meanwhile, rising number of diabetic and DR in low and middle-income countries. What is excellent intervention? For developed country, excellent intervention is referring to increased awareness through public health education efforts, early detection by DR screening, sustained with the control of the systemic risk factor, and the availability of effective tertiary level treatment. Therefore, it cost-inspired low and middle-income countries. For example, India early stage treatment intervention of DR, and Malaysia screening guideline provide screening guideline for DR. It means that annually screening for DR. Okay, this is a figure 3 that show how working principle of the fundus camera. Actually, fundus camera is non-mydrotic and it is primary tools for diabetic retinopathy screening protocols, user and patient friendly and cost-effective procedure, high sensitivity and specificity. Okay, for scenario of diabetic retinopathy, job problem and solution. For problem in diabetic retinopathy, quality of fundus image procedure often suffer from uneven illumination, color distortion, blur, and low contrast. So, therefore, solution for the rise problems, hybrid of image enhancement techniques and artificial intelligence in existing medical screening and diagnosis evolve. Objective to achieve for the research have three. First, to review and understand the basic image enhancement technique practiced in medical domain. To perform a test using retinal fundus image on different techniques in image to perform a test using retinal fundus image on different technique in image enhancement and determine the suitable image enhancement technique for diabetic retinopathy. To improve the quality of the retinal fundus image to be processed on the next stages. Okay, for the scope of this study, we use 90 abnormal fundus image captured from Hospital University Science Malaysia, 65 for MPDR, and 25 for PDR. This is NPDR, not typo. This is typo, actually NPDR. Okay, for the literature review for this study, the tables show the methods, the advantages and disadvantages, authors and domain that currently that have been reviewed by us. For example, histogram, HE, image negative, and contrast rating. Our methodology proposed for two steps, which are pre-processing of fundus image, was included image acquisition, then converting to grayscale image, next applying image enhancement method, which are histogram equalization, image negative, gray level slicing, brightness enhancement, contrast stretching, low light image. And then finally we evaluating the performance by using PSNR, MSE, and entropy. Then the second step is about model prototype by using App Designer for MATLAB software. This is our model prototype for this study. Finally, the resulted image from the findings. For figure A, this is original image. B, C, D, E, F, G is the resulted image from HE, histogram equalization, brightness enhancement, contrast stretching, image negative, gray level slicing, and finally, and the last one is, the last method applied is low level image. From the resulted image, ophthalmologists preferred for from the resulted image, ophthalmology preferred CS methods for further analysis as the image produced can easily interpreted. Based on expert review, our team collaborator from HUSM, Associate Professor Dr. Zunaina Embong, HE for histogram equalization resulted image from HE. It looked like very bright image, especially in the central part, and in some details in the middle are not available for analysis and missing details for optic nerve. And for BE, quite good, which can detect the abnormalities, but the diffusions of the abnormalities with background are not so prominent. For CS, ability for her, this method ability to detect and recognize the abnormalities clearly. The blood and hemorrhage is black on color. Heart exudate defined with the white color and blood vessels determined with blood in color. For image negative and gray level slicing, it looks like reverse of CS, retinal fundus image, where the blood determined with white in color, heart exudate black in color, and blood vessel white in color. And the image attend a bit difficult to detect the abnormalities as the brain need to reverse the information from yellow in original image become black in color in reverse retinal fundus image. And finally, for the last method that applied to the sample that we collected from HUSM, the same image as CS methods but looks darker. To evaluate the performance of method was applied, we use PSNR, MSE, and entropy. And for quality good image, supposedly PSNR value is infinity, and 0 MSE value and higher entropy value. From the result for this study, we get BE method show the highest value of PSNR, while MSE BE method also shows the lowest MSE value. Sorry. And GL, gray level slicing, give the lowest entropy value, which is 4.01. As a conclusions, quantitative result referring to BE methods should contradict with the qualitative outcome, which prefer the CS methods. CS method become the preferred method chosen by the ophthalmologist to be used for image enhancement of retinal fundus image. Further experiment and analysis must be done to obtain a better output and can synchronize within quantitative and qualitative output. And further discussion need to be done focusing on advanced image enhancement optimization. Further discussion need to be done focusing on advanced image enhancement and optimization to obtain a high quality image. And this is a list of references we use. And finally, we acknowledge for this study to our team members of diabetic retinopathy, including from University Utara Malaysia, University Technology Mara Penang, Department of Ophthalmology, Hospital University Science Malaysia Kelantan, and Ministry of Education for funding under SO code 14404. Thank you.